My name is Derek Manzello. I'm one of the PIs in the Ocean Chemistry and Ecosystem Division. Today I'll be talking to you about the in situ climate change and ocean acidification monitoring that we're doing here at AOML on U.S. coral reefs. But to begin, I want to give you a little brief background of basic coral biology. Corals live in a symbiosis with symbiotic dinoflagellates, collectively termed zooxanthellae. Now these symbionts can provide up to 95% of the energy requirements of the coral host, but the symbiosis is highly sensitive to elevated temperatures, such that temperatures in excess of 1 to 2 degrees Celsius, greater than the climatological maximum, will lead to the breakdown of the symbiosis, expulsion of the symbionts, and coral bleaching, and the corals turn white and become metabolically compromised. So in the most severe marine heat waves that we've heard about, it can lead to mass coral mortality if things cool off. Corals can recover, but then they are susceptible to disease, grow slower, have impaired reproduction. Bleaching events are increasing in severity and frequency, such that we expect annual bleaching within the next 20, 30 years in the Caribbean. This leads to the National Coral Reef Monitoring Program that was spearheaded by the Coral Reef Conservation Program. It's co-funded by the Ocean Acidification Program. With NCREM, as we call it, we are working to understand the impact of climate change and ocean acidification on U.S. coral reefs. More specifically, we want to know how these changes are manifesting in space and time, and what these changes in the physical environment mean to the ecosystem. So what are the ecological impacts on U.S. coral reefs from warming and ocean acidification? So NCREM has many partners. We work with 3 national marine sanctuaries, 3 national parks, 2 fisheries science centers, NCOS, PMEL, and multiple academic partners. And each of these partners plays a crucial role that allows us to execute the NCREM operation. So for our ecosystem response monitoring, the first thing we do are landscape mosaics. So these are high resolution images stitched together. So this is 10 meters by 10 meters at 2 of our Sentinel monitoring sites at Cheeca Rocks and Flower Garden Banks. And this provides a high resolution archive. And the utility of this is we can fate track individual coral colonies through time. So you see we had back-to-back bleaching in the Florida Keys in 2014 and 2015. And you can see the individual colonies bleaching in both years and then recovering in 2016. We do ReefBudget monitoring. We basically monitor the abundance of all the carbonate producers and eroders on the reef, and we contributed this to a Nature paper that showed that reefs aren't keeping up with sea level rise, which is impairing their ability to buffer impacts from storm damage and coastal flooding as sea levels rise. We also measure coral calcification. We take coral cores every 5 to 10 years. We use our CT to analyze these, and this gives us a long-term baseline by which to gauge future change. And you can see this is a record from the Flower Garden Banks. We're monitoring bioerosion. Ian talked about this using the Bioerosion monitoring unit. This was developed by Ian. We deploy these on the reef, collect them after 3 years, and then use a CAT scanner to volumetrically determine how much of the block has been eroded versus how much accretion has occurred on it. For secondary accretion, we're using calcification accretion units. So this is measuring non-coral secondary calcification, mainly due to crustose coral and algae, which is all this kind of pink stuff that grows on there that's important to reef accretion and development. At a select few Sentinel monitoring sites, we are monitoring the magnitude and rate of ocean acidification using the MAP CO2 buoy. 2 of these sites are fully implemented in the Atlantic and the Pacific. AOML led the establishment of the MAP CO2 buoy at Whangatali Bay in American Samoa this past May with our local partners at the National Marine Sanctuaries and National Park Service. These partners are currently collecting our calibration validation samples for us at the buoy. We're also monitoring vertical thermal structure using thermistor arrays across depth gradients. Just swapped all those out in the Keys last week. We're taking CO2 snapshots. Our collaborators at Southeast Fisheries Science Center and NCOS take these bottle samples for us during the normal NCREM operations, allowing us to get CO2 snapshots once every 2 years for each jurisdiction. Some initial results, we've seen unprecedented warming in the Florida Keys, such that the number of thermally stressful days per year has increased more than 2,500% in the last 20 years. 2014 and 2015 were the 2 warmest years on record. In spite of this, we've seen some signs of hope. There was a marked resilience in coral bleaching at our Sentinel monitoring site in the Florida Keys, such that this site bounced back and is actually a refuge for the ESA-listed Orbicella annularis species complex. This led us to propose to the sanctuary that they expand the sanctuary preservation area, which is currently under review right now. We've also documented localized acidification from navigational inlets in Southeast Florida. We found that nearly half of the reefs in Puerto Rico and the USVI are already net erosional. Almost 90% of the reefs in the Florida Keys are already net erosional. In conclusion, we need to do a careful accounting of all the carbonate producers and eroders on a reef as a prerequisite to determining ocean acidification impact. Warming is significantly impacting U.S. coral reefs, but there still are some signs of hope. Many reefs are already erosional because most of the coral cover has been lost since the late 1970s due to bleaching and disease. And our NCREP monitoring is feeding into the new NOAA omics portfolio as we've identified heat-tolerant coral genotypes that we are going to use to reseed bleaching impacted reefs. Thank you.